Hey everyone, hope you're all doing very well. Welcome back to another one here on the channel. In today's video, I got a good one here for you. We're going to be going through a charger review, and this charger is even more impressive than the last two chargers that we've taken a look at here on this channel. Let me introduce the charger that we're going to be looking at here today. This is known as the V6PRO from GT Power. It's got a lot more power packed behind it that we're going to go and explore those specifications here very shortly. What I'm going to do is go through those specifications. I'm going to show you exactly how we can get this charger working in terms of all of the selection options that we have when we take a look at the main screen. We're going to see what kind of other options that this unit has. I'm also going to take a look at functionality and capability that I've also never had on any charger that I've ever owned, and that is the ability to charge my cell phone wirelessly. This charger has that kind of capability. We're going to be going through that. I'm also going to go through a couple quirks of this unit, some oddball unique things that I just want to go and touch on as we go through the specifications first. We'll have to come back to this in a later section of the video. So let's jump into it, and I'm going to go through specifications as I see it right on the box here itself. So in terms of the specifications here, we got AC power that can be input here anywhere from 100 to 240 volts. And then on the DC side, we got anywhere from 7 to 30 volts. So a bigger range of voltage there on the input side for your DC in. That range of input voltage will essentially allow you to use any type of power supply that you have. And as long as it's more than, let's see, 200 watts, you're going to benefit from using that. Otherwise, the AC input has the potential to deliver 200 watts of power, which is quite a bit of power, and it's going to handle most of your charging needs. Now on the DC side, if you do access a high powered value there, and it does say at the input voltage of 16 volts. So if you have 16 volts of DC going to it, you're going to have access to 700 watts of power, which is a lot of power. You can essentially charge two 6S batteries at 16 amps each, one per side, and that's going to give you the maximum of what this charger can do. And that is going to be essentially charging at a rate of 3C, which we never really do here on this channel for a battery that has a capacity of 5,000 milliamp hour. It's a little bit more than 3C, but you get the idea of how much power this unit actually packs. And then when we look at the input current, the maximum input current there is 32 amps, which represents 16 amps per side. Now, if we look at charge current and discharge current, we got anywhere from 0.1 up to that 16 amps times 2. That's because we got two channels on this particular unit, which is a huge bonus, being able to charge two separate batteries at the exact same time, but completely independently. And then we got discharge current of 0.1, selectable all the way up to 3 amps times 2, of course, that 2 channel again. And then when we look at the discharge power, we're going to be able to discharge at 15 watts times 2, according to these specifications, and the balance current is maximum at 1.8. Now I do have to touch on this specification because the balance current at max of 1.8 amps is a decent amount of balance current. One of the things that a lot of chargers don't have is this exact specification being that high. 1.8 amps is a lot higher. Most chargers will probably do around an amp, and maybe some of the lower grade chargers will do around half an amp or so. Upwards of 1.8 amps, that's pretty good. It's going to allow you to balance charge fairly quickly. If you have cells that are out of balance, you'll get those cells in balance fairly quickly, and that's really what it comes down to. And then the balance precision, that goes down to 0.01 volt, pretty standard. And then in the battery voltage, it can detect anywhere from 1 to 16 nickel metal hydride, nickel cadmium, and 1 to 6 for LiPo, Li-ion, and lithium high voltage. And then we got our lead acid battery there to 2 to 24 volts. Now, you also have, we mentioned this at the very beginning here, we do have wireless charger right on the top of the unit, as you can see pictured here on the charger itself on the box. And what that will allow you to do is charge your cell phone at 7.5 watts. All right, one of the first things that I'm going to do here is I'm going to plug in our charger. All I do is plug in our AC current, our AC power connector in the back, and it fires up. And it tells us that it's got AC power. And then one of the first things I'm going to do now that we have it powered up is use this feature that I've never had on a charger. Now, obviously, this is not something that most would probably need with a charger, but if it comes for free with the charger because you already have to pay for it anyway, then so be it. So I'm going to try that out and see if we get something to charge. And yes, right away, it's coming up on the phone and it's charging. And I get a little bit of an icon there at the top left that it's charging wirelessly. So it does show you that it's using that type of functionality. And we can leave that there and it'll probably charge, but for the time being, I'm going to pull this off so we can visually see everything very clearly. And then what we're going to do here is we're going to take a look at some of the functionality that we can access. So the first screen that we get is this one where we can see channel 1. We can also see channel 2. And we want to select channel 1, which is going to represent this battery. And we got into channel 2. This bay here is going to be the 3-cell small 2200 that we have on the right-hand side. So both these are in standby mode. I can go and enable one of those by getting into specifically that channel. Here represents channel 1. And now if I want to do something with this battery, I can now click the button here and I can scroll up to make sure that we have specifications matching what we want to do. So this is a lithium polymer battery pack. We can choose between the LiPo and all the other different battery types. So we're going to choose that lithium polymer and then we can select the task that we want to actually complete. Right now I want to charge it, so we're going to use that, but we also have balance. We got fast charge, discharge, storage, and repair. So repair, we talked about that in a previous video, and what that essentially does is it'll help out cells that might be low by giving it a very small charge current. If you're going to use this type of functionality, I would highly recommend watching it every second of the entire duration you're using that type of functionality to repair a battery pack. So now what I want to talk about is the fast charge mode, because there might be some confusion as to what is fast charge versus charge. Fast charge is going to manipulate the constant voltage section of the charging sequence, which is right at the very end when your battery hits maximum voltage. It's going to terminate your charge sequence when you get to 1/5 of the original charge rate, where your typical charge mode is going to do all the way up to 1/10 of that, or 10% of your charge rate. For example, if we choose 5 amps as our charge rate, we're going to go and terminate the charge at 0.5 amps using that 10%. But if we wanted to actually use the fast charge mode, fast charge is going to cut it at 1 amp versus that 0.5 amp. So discharge is obvious, that discharge it. Storage is obviously going to allow you to store the battery pack. You're going to be able to select the voltage that you want to go and store to. And then repair, we did talk about that. So let's go and select that charge mode, select a cell voltage of 4.20. Now we can change this, and the range that we can change this is all the way down to about 4.0 volts. There it is, 4.00. And that's really good because if you want to select a lower voltage, this is going to help prolong the life of your batteries if you don't need to charge to 4.20. I highly recommend doing that. And if you want more information, I'm going to leave a link in the description below that'll talk about that specific topic. So 4.2 is what the standard is. We're going to leave it there, and I'm going to take the charge current down from 16 amps. Let's make it a 1C charge here and go at 5 amps. So 5 amps is now selected. And then here, all we need to do is start the task. Once we check and hit that, we then see the screen says that it's set it up for success. It reads it as success. And then we get this screen displayed in green. So you'll notice that we do have green here. When the charge is complete, it does turn to blue. Our charge current is ramping up quite quickly on this charger, which is what I like to see. I like to see these things fly up and know that it's charging a battery that can handle a 5 amp charge without coming up to peak voltage, which it already knows and has determined. And we can see the actual amount of watts that's being put into the battery there at 119 watts. And if we actually hit the enter key, right now you can see it's actually dropping, and then it's going back up. That actually just measured at the 30-second mark or so our internal resistance. So I really like to see that. Here you can see this battery is quite tired, and it's getting milliohm readouts there of 4.7 all the way up to 6.3. So I can't wait to be able to compare that against other chargers. That's the whole point of all these videos that we're doing here. So you can see the voltage readouts there also of each one of those individual cells, which is good to see. And then the main screen shows you the temperature of the unit, the voltage of the input, and then we also have the watt hours that the unit is using, and then the resistance of the battery. It's interesting that the only spec here about the battery is the bottom right. These other ones here are all about the charging unit. And then we have the main reading there where we get to see the time, we get to see the charge current and the milliamp hour. So that's essentially what happens when you're in this type of charge mode. Now we're going to leave it doing this, and we're going to switch over into our second channel. So we just hit our channel selection button, and then we go into this setting. Now for this pack, what we'll do is we'll try a storage functionality here, and we're already selected on the storage mark. So this is how we get it, by selecting that, and then we check our cell voltage spec. Now we can go and take this up to anywhere between 3.80 to 3.85. So it does recommend the charger itself. 3.8 is a good voltage per cell to actually store the battery pack, but anywhere between 80 and 85 is going to be fine for storage. That's pretty well the standard. We're going to select 3.85 just in case it already was at that 3.80 volt mark, and then we're going to choose the current settings as well as the cell count. So cell count is 3S. You got options here all the way from 1 to 6. So we're going to select that 3 cell, and then the current setting at 2, we're going to go and bump that up to 2.2 because this is a 2200 milliamp hour battery pack. And now from there, we can go ahead and start that task. So it checks it, sets it up, reads it, and then we're good to go. I like how quick that sequence is for it to check what is going on with this battery pack, and then right away we get up to that maximum within a few seconds. So I like to see how it ramps up really quickly. Now we get a purple screen when it's in this particular mode because we are doing a storage charge. Now we do get our internal resistance marks for this particular battery, even though we're in a storage mode task here, and that is quite cool. And I think it's because this particular setup ended up needing to charge the battery to get that storage mode, and anytime you're charging the battery packs, that's when you're going to get this readout. It has to be balanced charging, and then you're going to get the readout for each one of those cells. Now what's really interesting, and I do want to read this because it gives you a pro tip for this type of functionality. GT Power themselves recommend that higher charging currents for batteries with big capacities and low internal resistance are going to help the testing value of the internal resistance to become more accurate. This is not an IR meter, it's not an IR reader. This is simply a charger that gives you that type of functionality to get IR values out of it. But if you use charging currents that are higher for bigger batteries, for example, our 5 amp hour, rather than doing 5, charge at a rate of 1.5 C, that would be 7.5 amps, you're going to get better readouts. And you want to make sure that the readings always come from a charge readout of 7.5 amps, and you don't want the battery pack to be ramping down and then the charger takes a reading. So we're going to access the main screen now that both of those functionalities are in standby mode. This is the only place that we can actually access it when the charger is not performing any task, because you're actually changing parameters of the charger, which would not be good if the charger is already functioning. So we got safety timers under task parameters, we got max capacities, as well as the end current. We did talk about that 1/10 of the current. You can actually adjust this. This is the only charger that I've ever had that allows you to change when the charger stops the functionality. So for example, if your charge current was 5 amps and you want to stop the charge when it gets to 50% of that, that would be 2.5 amps. This is where you'd come to make that change. You're going to end up changing that constant voltage section of the overall charge cycle, which is really cool to see that you can change this functionality. So this is really for advanced users. If you do want to speed up your charging, it's going to leave you with a charge voltage of lower than 4.20, obviously affecting your overall capacity that you place in. So then you can turn trickle charge on or off, and those are the functionalities from this particular screen. So we're going to leave this here at 240. I didn't mean to go into this. We're going to go back one screen level, and we're going to take a look at system settings. Under system settings, we have the ability to change the language, the maximum input power there, the minimum input voltage. This is good functionality to have if you're using a lithium polymer battery pack to power the unit, when you can select the minimum amount of voltage that you want that battery to drop down to. So if you're using this type of functionality, or if you're using a battery pack, make sure you do use this functionality and understand what kind of value you should put there. Then you can change the LCD backlight, how bright you want that thing to burn. You can change the beep sound. This is right now on high, and the completion tone. You can get it to continuously beep or just have a single beep sequence that it runs through. And the device name, you can go ahead and also change that as well, and that'll show up for your unit. So that's really all the type of functionality that these two screens contain. A couple quirks that did come up here is with the specifications and the power supply within the internal unit. The internal unit, when you do plug it in, you do have some electrical noise that you can constantly hear buzzing away when that AC power is plugged in. So I found this a little bit strange. It reminded me a lot of the inexpensive power supplies in PCs when they seem to buzz and give you that electrical noise, if you know what I mean. I don't think I can capture this properly on the microphone, but I have a sense that you understand what I mean here. And then then if we look at the specifications again, what I did find is that the discharge overall wattage for each channel here was not 15 watts times 2. I actually found it to be 5 watts times 2, and we can see that clip right here where I'm discharging the battery packs, and I cannot get anything more than that 5 watts of overall power being discharged from the batteries. Another quirk here has to do with the input power to the unit. Right here, this line says DC max 700 watts, and it has in brackets that this occurs at an input voltage greater or equal to 16 volts. However, if you go and take the input current of 32 amps as a maximum from this particular line, multiply it by 16 volts, you're going to get an absolute maximum wattage at that voltage of 512. So really what I see here, in order to access that 700 watts, is you have to take the 700 watts, you got to divide it by the 32 amps, and the voltage of your input must be at about 21.88 volts in order to actually hit the full 700 watts of power. Just a strange thing that I don't understand in this particular manual here. Now, what I really like about this charger is the internal resistance functionality. It functions pretty good. It seems like it's quite accurate. We're going to be taking a look at not necessarily accuracy here, but comparing it to what values other chargers provide when we get internal resistance outputs from each one of these chargers. Ideally, what I'm hoping to do is be able to compare 4 different chargers from 4 different brands and then see exactly collectively what each one of them has for an internal resistance of the same battery. That's ultimately what we're working up towards, so that we can see the differences there that each charger may actually have and represent for the battery. Well guys, that pretty well does it for this video. I hope you enjoyed it. As always, like the video if you do. Don't forget to hit that sub button so that I can see you guys in that next video. Thanks a lot for watching. See you in the next one.